Well, it's an honor being here speaking in front of you all. Thank you for coming. Today I'm going to be talking about geomagnetism and what I've done over the course of this summer. We are going to put on our CrowdMag glasses today, and for those of you unfamiliar, I'm going to show you how to put on these glasses to see the magnetic world around us. We know that there is a magnetic field, but how do we see it? Through CrowdMag, it gives you your very own glasses to see this world. Everything needed for recording, for sending, for getting all of this information can be accessible through CrowdMag. On the right here, your right here, is a map of Colorado. It is a year old, but it does give accurate information to CrowdMag data that we've had. We measure magnetic data in nanoteslas, and on the right here is our scale. Colorado has a magnetic average of about 50,000 nanoteslas. That is from the World Magnetic Model that Manoj was a part of creating. And you can see that there is a variation. We have some low points here, some higher points, and it gives a good representation of seeing this world visually. If you're asking what CrowdMag is, it's a crowdsourcing smartphone app that allows you to collect and send in this magnetic data. It measures the magnetic field in real time, and it's just a fun app. It's a fun app to have. You guys got to download it. And the magnetic anomaly, we're going to be looking at some plots and some points that I think this, just to give a little background on what this is. It's a deviation from the magnetic norm, so we're going to be looking at some plots with some lines, and the high spikes, those are going to be our anomalies. Our experiment is going to be collecting data from 12 different people, 12 different phones, and looking at these anomalies, comparing them to see a different data from that. CrowdMag came to be, it was just an idea, just a thought over lunch one day. Manoj was eating lunch and a few others, and they were talking about looking at this world through another set of eyes. And they already had the World Magnetic Model, which is just the model of the magnetism throughout the world. And Google was interested. They were interested and wanted to see more. And so they contacted Manoj asking if they can see more through another app. And since then, it has had a rough start, but it's come to be a lot more than just an idea. This was the process taken to get our data. We had a few questions on how noisy are the data from individual phones. What kind of anomalies will we see in these urban areas? We also asked, can these measurements be repeatable throughout the phones? Can we see some similarities in between? And what kind of features, could we use these features as a source of possible navigation in the future? So first, we need to download the app. I really recommend downloading the app. We have a map here that we planned out of the traverse that we plan to take to keep it relevant, keep all the data points together. I made a plan of materials we would need, of the people that were going to be there, the types of phones, if there's differences in iPhones versus Android, and that was made through Google Slides. Over here we have, this was actually from our actual experiment day on CrowdMag Day, we recruited some people to send us some valuable data. And step 5 was collecting all the data, gathering it, putting it together, and analyzing it. This was our CrowdMag Day on July 12th. Over here, that was our starting point at the RECCS building. And I didn't get everybody in here, but this was the beginning. We were just going over logistics and everything for that. We measured out points in chalk here. Every 50 feet or so, we measured in 10 paces, and it was such a fun experiment. Over here is the data we collected. Manoj had a great idea of doing a practice traverse 2 weeks prior to our CrowdMag event here with just 4 phones. We used 2 iPhones and 2 Androids, and we did see a little bit of variability in between the two, but not much. You can see these anomalies here do line up fairly well, which was great for us to find. These were the paces taken, so each individual number, 1, 2, 3, is 50 feet apart. And we did stray a little bit on the practice path, which was great that it was a practice path. And over here, everything, if we were to, this is a stacked plot. If I were to put it originally, everything would be stacked on top of each other. All of them start at 50,000 nanoteslas, but just for the sake of separating them so you can see them all, there is an offset of the numbers there. Below is the statistics that we came up with, and you can see that the mean and median do fall about 50,000, give or take. So that was also great that we're seeing this repeatability. The standard deviation is a little bit less than 10,000, so that's good to see. To see just the standard deviation, how much of it deviates. That determines our anomalies. 10,000 more than 50,000 or less. And over here is our CrowdMag data from CrowdMag Day, and you can see that the anomalies do line up. This large guy here is this one here, and there are still the 1, 2, 3, and 4 that we see here. We did get an extra one because we strayed a little bit, but there are the 4, so we did see that there is repeatability between the two. Over here is our mean and median, which also stay very close to the 50,000 mark. We did get an outlier here. I omitted it here. We determined that it was an outlier, but I did want you guys to see it here. It's a very large difference. So we did leave that one so you can see. It was great that we did take a practice path so we could fix the kinks and all of that. We did decide to use chalk because the first time we did this, it was counting out 10 paces and walking at the same time was very difficult for me, so using chalk was great to just hit the record button on that. And it made it simpler, it made it easier to do. And as I mentioned, we did omit some points. We agreed that they just did not fall in line with the correct data. Conclusions, we did see that they are fairly similar. They all stay within a similar range. There is repeatability between the phones. Little bit of difference between iPhone and Android, but still you can see that they all fall around the same measurements. One thing that we did notice is calibration. We would calibrate our phones beforehand in order to make sure that we don't see any craziness, any crazy outliers again. That would be nice to do. So based on this experiment, we do see that future navigation could be possible. Of course, we'd like to tweak the app a little bit, make sure everything's okay, that we get more accurate locations, but we do see it as a definite possibility in the future. This next picture is our CrowdMag crew that we got our data from, my mentors that I have to thank so much, and all the RECCS group and everybody here. So thank you very much.